Section 41 through 44, we have two division problems and then two absolute value problems. Remember, division just really requires multiplication by the complex conjugate of the denominator in order to get i's out of the denominator. Remember, the complex conjugate of a complex number, a plus bi, is a minus bi. We're looking for the complex conjugate of the denominator, since the denominator is where we want to get rid of the i's. 2 minus I in the denominator of number 41 gives us a complex conjugate of 2 plus I. We're going to multiply the whole fraction by 2 plus I over 2 plus I, which is just another name for 1, which allows us to do this multiplication. Remember, to multiply fractions, it's top times top and bottom times bottom. On top, we'll do the distribution. 7i times 2 is 14i. 7i times I is 7i squared. On the bottom, we'll do FOIL. 4 plus 2i minus 2i and minus I squared. Of course, this is the reason that we chose the complex conjugate, because we knew that those middle terms would drop out. On top, we can simplify, because I squared is equal to negative 1. We'll have negative 7 plus 14i. On the bottom, for the same reason, I squared is equal to negative 1, we'll get 4 plus 1, which is 5. We're going to do number 42 the exact same way. We're going to choose the complex conjugate of the denominator, or 1 minus 6i, and multiply both top and bottom by this number. We'll have to do double distribution on both the top and the bottom. On top, we get 2 minus 12i plus 7i minus 42i squared. On the bottom, we get 1 minus 6i plus 6i minus 36i squared. Simplifying, we get 2 minus 5i, and negative 42i squared becomes plus 42. On the bottom, again the two middle terms dropped out by the design. Negative 36i squared becomes plus 36, and our denominator is 37. On top, we just need to combine the two constant terms and get 44 minus 5i over 37. Let's look at 43 and 44. These are absolute value problems. Remember that absolute value really means distance from 0. When we look at these problems, we are thinking about our real and imaginary axes. And if you consider the point 2 minus 3i over 2 to the right on the real axis and minus 3 on the imaginary axis, what we're really asking here is how far is this point from 0? Of course, we can use the Pythagorean theorem to find this value. We have a formula taken from the Pythagorean theorem, which looks like this: absolute value of a squared plus b squared. Remember, our complex number is a plus bi. We don't need the I for our formula. Square root, in this case, a is 2. 2 squared is 4. b is negative 3. Negative 3 squared is 9. And our answer is the square root of 13. Let's do the same process for number 44. In this case, we're looking for the distance of the point 5 plus 12i from the origin. The formula gives us square root of 5 squared is 25, and 12 squared is 144. This is the square root of 169, which is a perfect square of 13.